So today I'll be solving this question, which is from the topic of graph. Uh, that is the breadth first search, and from here on I'll be solving a few of the common sort of graph questions that are asked in the DSA interviews of various product-based companies. The first one of this being the very easiest of all, that is the BFS. Let me first read the question for you and then explain it with the help of the examples given, and then we'll proceed to coding it. So given a directed graph, the task is to do breadth first traversal of this graph starting from 0. Note, one can move from node U to node V only if there is an edge between U to V. Find the BFS traversal of the graph starting from the zeroth vertex from left to right according to the input graph. Also, you should take nodes directly or indirectly connected from node 0 in consideration. Okay, fine. So what they want us to do is we are given with this directed graph, and directed as a term is important because they said one can only move from node 1 to node 2 if they are connected to each. I mean, if there is a valid edge, let's say 0 and 1 are connected, but from 1 to 0 we don't have an edge, but from 0 to 1 we do have. So we'll only consider the path from 0 to 1. So that is what they meant. What breadth first search is, we'll go through all the nodes of like all the vertex of the graph, and then what we'll do is we'll explore it in completeness. Let's say we visit 0 first, and then we'll go from 0 to 1, we'll go from 0 to 2, and then we'll go from 0 to 3. Only then is when we'll explore the other nodes, that is 1, 2, 3, and all. And if we go to node 1, let's say 1 has no subnodes under it, so 1 is in itself complete node. That is, there is no more nodes that we can explore from 1. So from 1 we can come to 2. Then from 2 we'll have to explore this 4 first, and then let's say 4 has 2 more nodes, so we'll have to explore those as well. But here in this case there isn't any, so from 4 we'll go back to 2, and then we'll go back to 3. So we'll explore 3, and that is the way it goes. So from one node we'll have to go to all of its subnodes, and then let's say if the subnodes that we went has further nodes under it, we'll have to explore them as well and then go to the other node. So this is how the breadth first search work. You are traversing a graph into its breadth. Let's say you go to one node, you completely go to its breadth, let's say depth in this case. So now we'll code it. We'll use the data structure Q, and let's say we'll first, what are we given with? We are given with, let me come to C++. Okay, so we are given with the number of vertex V. What we'll do is we'll make a visited array V in order to keep track of the nodes that we have visited so far. We'll initialize that with false, and we'll have a data structure Q. We'll push the first, push 0 initially, and we'll mark visited of 0 is true. Now in this question we haven't been given with any source node from where we can start the BFS traversal, so you can use any of the nodes. So that is why I'm starting with very base case, and visit of 0 is equal to true. And what will go is, well, while Q is not empty, node will take the node. What is node? Node is Q dot front. Okay, now you had extracted the node, so now you can pop it. You can now explore this node. First mark the node that you have took as true, and you can further explore it because you have been given with the adjacent nodes. So let's say for 0 the adjacent nodes will be 1, 2, and 3. For 2 the adjacent nodes will be 4. Mind you, for 1 there is no adjacent nodes since the graph given is directed. It is only from 0 that we can go to 1. We cannot come back from 1 to 0. So that is the case you should keep in the mind, at least for this question. So you'll explore this node completely, right? So what you'll do is, for auto id in distant element, I mean node, let's say you're taking, right? If it is not visited, so if not visited of id, visited of id, you visited, right? So you visited of id is equal to true, and since you have visited it, you can put that into the queue for it to, completely, for us to uh, completely, visit it, like visit its subnodes. So we'll push this node that we have got into the queue, and okay, fine, we'll have to use this. We have to store the traversal as well, right? So this is the array BFS, to which will push the elements that we have traversed. BFS that pushback node will push that here, and I guess this should do, because we'll keep on pushing the nodes, and the popping thing, like this the upper part, I mean this part will take care of pushing the node into the BFS array, and this part will take care of exploring that node into its completeness. So I guess this should possibly give us the correct answer. Let me run this and see. Hmm. Visited was not declared. Okay, yeah. Bool visited. We'll have a bunch of errors. We'll keep on resolving them. While not queue empty. Okay, fine. This is a function. So, okay, I guess we are good to go. Let me submit this and see. That is all for this video. I hope you liked the explanation, and we'll meet you in the next one. Thank you.